guys, nice to see everyone again. Welcome back to this channel. Make sure you have subscribed to my channel for more videos. And for today's video, we'll talk about topic 9. And in this topic, we are going to talk about reaction kinetic. We have two subtopics to cover. The first one is your 9.1 rate of reaction. And then you have your 9.2 factor affecting the rate of reaction. How can we make it faster or how can we make it slower? And for this video, we are focused on your topic 9.1 rate of reaction. And in this part of video, your part 1, we are focused only on one thing, which is how to define and determine the rate of reaction by using experimental data or by using graph of concentration against time. What is actually reaction rate? What is that? Reaction rate is actually the change in concentration of a reactant or a product with time. That is your reaction rate. You should know that the rate is inversely proportional with the time. Okay? So when the rate is very high, the time should be very short. What is meant by that? If the reaction is going very fast, means your rate is very high. Therefore, the time taken for the reaction will be very short because it's going very fast. So, from your reactant to become the product, the time taken will be very short. That's why the rate is inversely proportional with the time. The shorter the time, the faster the rate. The longer the time, the slower the rate. That is what is meant by reaction rate at this moment. So if I have a reaction between A changing to B, how can I write them in mathematics? Your rate can be defined in two terms. One in the term of reactant, another one is in the term of product. So when it's in the reactant, you can see that rate is equals to negative change in concentration of reactant over time. So that is my reactant. So this is my reactant. So the change of concentration of reactant, the square bracket of concentration, over the change in time. So the D over here is changes. Alright, change in concentration of reactant over time. What is meant by negative over here? Negative over here means it will decrease. Why it will decrease? Because it's a reactant. During a reaction, your reactant will decrease while your product will increase. So, to identify whether it's a reactant or product, we are going to use the symbol positive or negative. Negative represent it will decrease. So, your reactant will decrease. That means your A is your reactant. So, when the change of reactant over time, we'll use the symbol of negative to represent the concentration of reactant will decrease over the time. If the concentration of reactant is decreased over time and represented by the symbol negative, what about product? What would be the symbol of product? So as you can see over here, for product, the symbol will be positive because the positive represent increase. You know that in a reaction, the concentration of product will increase along the time. And you can see over here, rate equals to positive changes in concentration of B. The square bracket of B represent concentration over changes of time. So the DT, the D over here represent changes. So the T over here represent time. So that is the way that we write rate of reaction for reactant and for product. The symbol of positive or negative over here, the symbol, is a must to be written together in your formula of rate because it will represent whether your A or your B is a reactant or product. As we have agreed just now, the rate of the concentration A and B will be written as given. What is the symbol negative and positive stand for? Why is that a square bracket? And so on. We have explained this formula. And if we want to put them into a graph, your graph should look something like this. Concentration versus time. So look at the reactant first. I have my reactant A. So you can see that the concentration of reactant A will decrease along the time. You have your concentration very high at the beginning. That is the concentration A initial. So we started off with a high concentration of your reactant and it will decrease along the time. While for your product, you have your product B. That is your product B curve. So in your product B, you started off with the concentration of B initial is very low. It's zero. It's basically zero. And the concentration of product B increased along the time. It's very similar to what you have learned previously in your previous chapter. Okay? So always remember, when it's a reactant, the concentration will decrease. And always remember, when it's a product, the concentration will increase along the time. So remember that. As a conclusion, your rate can also be written like this, where rate equals to negative D concentration A over dt equals to positive of changes in concentration B over time. So your rate formula can be written like this. And what would be the unit of the rate? The unit of the rate, as you can see over here, is a concentration. So the unit can be in mole per liter, can be in mole per decimeter cube, or it can be even in molar. So that is the unit of concentration, while time can be in watt unit. So let's look at the example of unit that we have. The first one, it could be mole -1 time -1. That is your concentration. That is your time. Another one, other than mole liter -1, it can be mole decimeter cube. Alright, over time. So same, that is also your concentration, that is your time, obviously. Last but not least, it can be as simple as molar over time. So you can see that is your concentration over time, okay? But what would be the time? The time will depend on the question. If your reaction is fast, then it could be in second. If your reaction is slow, it could be minute, days, month, year, and so on. Your time can be as small as second, alright, minute. It can be in hour, it can be in day, it can be in months, it can be in weeks, it can be in year. So the example of the unit could be ms -1 for concentration over second. Or it can be concentration minute -1, concentration where the time is minute. It could be molar year -1, where the time right now is year. So you take probably 1 year or 2 years for your reaction to finish. So your concentration over the changes of time, the time right now is in year. It could be hour -1. Concentration over time, where your time right now is in hour. Okay? So it depends on the question. Be very careful with your time. Read the question carefully. Make sure you know the time is measured in what unit. Alright, so we know everything about rate right now. Okay, we know what is actually rate stand for, what happens when the rate is fast, what happens when the rate is slow. We know what is the symbol of the negative and positive stand for. We know why is a D concentration, what is the D, what is the square bracket, what is the dt. We have learned all that just now. So the question over here, when we say changes in concentration and changes in time. So how do I calculate the changes? Very simple. The changes in concentration and the changes in time can be calculated by using a very simple formula, concentration final minus concentration initial over T final minus T initial. So you can see over here, the negative remain unchanged, guys. The negative remain unchanged represent is a reactant. Okay. For the product is the same. The positive of the product still remain that. Alright. The positive will be there because it's a product where the concentration should increase along the time. And you can see the formula is similar, where to have the changes in concentration and the changes in time is just simply by using the final concentration minus the initial concentration over the final time minus the initial time. Okay? Just a kind reminder over here, your time initial and time final must be in the same unit because you want to minus them. If your time initial is in minute, your time final must also be in minute. Alright, must be in the same unit. Don't worry, we'll look at example on how to use this formula later on. We have two types of reaction rate that we will look into. The first one is your average rate of reaction. The second one is your instantaneous rate of reaction. What is actually average? What is instantaneous rate of reaction? Average. The name average brings the meaning. Average means we are going to calculate the rate over a period of time. Let's say I want the rate from time equals to 20 seconds to 100 seconds. So I need to find the average rate of reaction from time 20 seconds to time 100 seconds. Okay, obviously that will be my initial, that will be my final. Can you see that roughly? While instantaneous is actually the rate at a very particular time or a very specific time. Okay, where we only have one time, there is no in between. We want to calculate the rate at 100 seconds. So I want to calculate the rate of reaction at 100 seconds at that particular time. So you can see the difference over here. The average means there is a period of time, a moment, okay? While instantaneous is at that moment. There is only one time at that particular point we want it, okay? We'll look into your average rate of reaction first. For average rate, we have two methods to solve the question for average rate. First one, we can use formula. The formula as what we have learned just now. Negative over here, obviously for reactant. And positive over here, obviously for product. But the formula is similar, still final minus initial, final minus initial. Doesn't matter it's a product or reactant, it's still final minus initial. Your formula is included the symbol of negative and positive. So make sure you have that, okay? While the second method is by using graph. What graph? Concentration versus time curve. We are going to plot a graph and we are going to use the value that you plotted into the graph from a concentration versus time, and we are going to calculate the average rate over a particular time, depends on the question. So don't worry, we have example for that. And the example 1 of average rate is given as below. Calculate the average rate. So we are looking for the average rate of reaction from minute 20 until minute 180. So you can see over here, your time is in the unit of minute. When the concentration of reactant X, alright, it's a reactant, therefore it decreases from 2.75 molar until 0.18 molar. So as always guys, we'll take out the information first. Question asking for average rate. Okay, so we need to roughly know that your rate formula will be negative. Why negative? Because it's a reactant. So your rate formula, you will be using the one in negative. The other information that we have is the time initial. The time initial given is 20 minutes. Okay, and then you have your time final. Your time final given is 180 minutes given in the question. From 20 minutes until 180 minutes. The concentration of reactant X decreases from 2.75. So the concentration of X initial will be 2.75, your initial. And then your X will drop until 0.18 molar. So that is the concentration of initial, that is the concentration of final, because the reactant concentration decreases from 2.75 to 0.18. And if you look at the way I write, I will group them together for all initial or final. So you can see very clearly, your concentration over the time is decreasing. That's why it's a reactant. So the rate must be in negative. So the formula that we will use is rate equals to negative because of the reactant. And if you look at the way I write my formula, I'm no longer using A, guys, because I don't have A. My reactant right now is X. So substitute your reactant into your formula. Is the concentration of X final minus the concentration of X initial. That should be your correct formula. We are no longer having A. Your reactant right now is X. So X final minus X initial. And then the time will be, as always, time final minus time initial. To find the rate, we put in all the value. Make sure you have the negative remain. So the negative remain over there. The concentration X final is 0.18. So you have 0.18 minus the concentration initial 2.75 over the time final is 180 minutes minus 20 minutes. So as you can see over here, you cannot mix up the initial and final. They must be the correct value. Press your calculator and make sure the negative is still there at the beginning. So you have your negative 2.57 over 160 minutes. Solve it. Negative times negative. Your answer of rate will be a positive value over here, where the rate will be 0.016. And what would be the unit? That is the question. So you can see over here, concentration is in molar. Time right now is in minute. So the complete answer should be 0.016 molar minute negative 1. That should be the average rate of this question. So before you write the unit, make sure you check the unit of time. Make sure you know that your time is in what unit. The second example for the average rate, we'll be using method 2. So your method 2 requires graph. To save time, I have plotted the graph ready for you. So based on the graph plotted below, determine the average rate. So we are again looking for average of the reaction over 500 seconds for the formation of product A. So this is the graph plotted. The graph is concentration versus time. And because it's the formation of product A, therefore your rate must be in positive. Agree? Because it's a product. And you can see from the graph, guys, you can see from the graph of my product A right now is increasing. Looking at the curve of the graph, you already know that this must be the curve of a product because it's increasing over the time. So how do we use method 2 to answer the average rate? Simple. Look at the time that we want. We are looking for over 500 seconds for the formation of product A. 500 seconds means I'm moving from 0 all the way to 500 seconds. That is my 500 seconds. Okay? So what are we going to draw? Is we are going to draw a straight line. Alright? We are going to connect your point time 0 until point time 500. And then you are going to find the value of this point. The point 0 over here, the time is a 0 second, where the concentration is a 0 molar. And then you can have another point at 500. You can see over here 500. Therefore, the time is 500 seconds. And the concentration, you are going to extrapolate your graph. And then your concentration over here is 0.165 molar, let's say. Okay? So from this value, you can determine who is your initial and who is your final. Because it's a formation of product, obviously, your initial is when the time 0. Your final is when the time 500 seconds. So that is the information that I have for your initial and final. So next, what are we going to do? We are going to write the formula of rate. So the formula of rate equal here is positive because it's a product. concentration A final minus concentration A initial. I'm using back A because the product that I have over here is A. So concentration A minus concentration A initial. Time final minus time initial. Put in the value, guys. Make sure the positive sign remain over there, doesn't change. Your final concentration is 0.165 molar. Your initial concentration is 0. Over, the time final is 500 seconds. Your time initial is 0 seconds. So put it in. And work out your mathematics. Press the calculator correctly. So you will have 3.3 times 10 to the power of negative 3. So what would be the unit? Look at it. Concentration is in molar. Your time right now, look at your time. Your time right now is in second. Can you see that? So your time right now is in second. 0 second and 500 second. So the unit over here will be ms negative 1. So the unit, every single time, the unit of the rate will depend on the unit of the time because the concentration will be forever in molar. So to determine the unit of rate, you need to identify the unit of time. So make sure your time is in what unit. And for this question, my line is starting from 0 to 500 because I want to calculate over 500 seconds. So I'm starting from time equals to 0 second until time equals to 500 seconds. If the question say, let's say if the question say I want time at 200 seconds until 500 seconds. Alright? If you're looking for 200 seconds until 500 seconds, then your straight line will be from 200 seconds over here and draw a straight line to 500 seconds over here. Okay? So the straight line will depend on the average rate over what period of time. If you're looking from 0 to 500, then your straight line will be from 0 to 500. If you're looking for a 200 until 500, then your line will be from 200 until 500. Make sense? Okay? Simple. That is the two method of average rate. Next, we are going to look at instantaneous rate of reaction. As we have mentioned just now, instantaneous rate means the rate at a particular or at a very specific time, at 1 second or at 1 minute and so on. Okay? We only have one method, basically, very simple method by using graph. And we have two steps. One simple step is you are going to identify and draw a tangent at that specific time. So my specific time, this is my specific time. So this is the time that we have. And what are we going to do is we are going to draw a tangent over it. So draw a tangent means you're going to draw a triangle over the time. Okay? And what are you going to do after you have a tangent? Simple, guys. You're going to calculate the slope of the tangent. And if you remember how can we calculate the tangent in mathematics, tangent in mathematics is your x1 minus your x2 over your y1 minus your y2. So that is how we calculate the slope of the tangent. The main thing right now is still to identify what specific time we are looking at. So bold that particular time and then draw a tangent over the dot and calculate the tangent. Simple. So the first example that we have for instantaneous rate over here is by using the graph given below. To save time, guys, to save time, that's why I give you the graph. In the exam, you might need to plot the graph on a graph paper. Okay, we will give you data and then you need to plot the graph. Then only you use the graph that you have plotted. Okay, and because I want to save time over here, that's why I give you the plotted graph. Okay, I want to calculate the initial rate. Initial rate means what? Initial rate means time equals to 0 second. And if you read the question over here, time at 0 second, that's why it's an instantaneous rate of reaction because we only have one specific time. I want the rate when the time is 0. So at time equals to 0 second. Okay? And this is the time at 0 second. Okay? Time at 0 second. This is my point. And what are we going to do? Like I have mentioned, this is the point that we want. What are we going to do is, we are going to plot a tangent over the line. Okay? And then you are going to calculate the tangent. So this is the tangent dot, this is the tangent dot that I have. So this dot, the time right now is 0 second. I know that it's a second because it's given. And then the concentration is 0.1 molar. Okay? And this point right now, you can see over there, the time is 200 seconds. Okay, we extrapolate, you have your time is 200 seconds and the concentration is 0.06 molar. Okay, and over here, who is your initial, who is your final? Look at your curve, guys. Your curve is decreasing. So when your curve is decreasing, the reaction of NH3 ammonia over here obviously is a reactant. And the rate that you use must be in negative because it's decreasing. Alright, it's definitely a reactant over here. And how can I find the instantaneous rate at time equals to 0? We are going to calculate the slope of this tangent by using the similar formula. Rate equals to negative the final concentration of ammonia minus the concentration initial of ammonia over time final minus time initial. So make sure the negative over here remain unchanged. Alright, make sure you know who is your final, who is your initial. Obviously over here, that is your initial. We started at time 0, so we finish at time 200 seconds. So your concentration final over here, final concentration 0.06 minus concentration initial concentration 0.1. Okay, over the time final, my final time is 200 seconds minus my initial time is 0 second. So solve the mathematics, you will have negative, the negative still remain over there, negative 0.04 over 200 seconds. So press the calculator, negative over here will be positive. Okay, so your rate over here will be 2 times 10 to the power of negative 4. And what would be the unit? Concentration is in molar, your time is in second. Look at the time second. So your unit will be molar per second. Simple. Alright? Very simple, guys. First step, the question will give you data, so you plot the graph. So after you plot the graph, make sure you identify the time that the question asking for. Alright? Identify the specific time that you want. And then you draw a tangent. After you draw the tangent, you calculate the tangent. So how do you calculate the tangent? Your x1 minus x2 over your y1 minus y2. Like this. Okay? Then you will get your answer. Make sure one last thing before you leave your answer. Check the unit of your answer. It's a concentration over time, but the time is in what unit? Okay? Alright, one more example before we move on for instantaneous rate. Your second example today. Same thing, we are going to give you the graph because I'm going to save time, but bear that in mind, in the exam, you need to be able to plot the graph, okay, by using graph paper. Here is the graph given to you, and the question is asking to calculate the rate at a very specific time, 600 seconds. For the reaction of NH3, again, if you look at the curve of the graph is decreasing. So you know that your NH3 is a reactant. And the rate that you are going to use will be negative. Okay, the formula of rate that you are going to use will be negative. And we are looking at the time equals to 600 seconds. So that is my 600 seconds. This is my point. So what are we going to do is we are going to draw a tangent over the time. Alright, we are going to draw the tangent. So from this tangent, we have 2 points, the first point and the second point. So the first point over here will be in what time? So if you look at the time, I have 400 seconds. And the concentration over here, roughly, I have the data. Alright, so it will be 0.042 molar. Over here, the time is 800 seconds. Okay, the concentration, guys, long way to extrapolate. Extrapolate by using your ruler. is 0.017 molar. So you have your 2 point over this tangent. Next, we are going to write the formula that we are going to use. The formula will be rate equals to negative because we know that your ammonia is a reactant. Look at the curve, we know that, alright? Your curve is decreasing. So it's a reactant. Negative, concentration final minus concentration initial over time final minus time initial. Look at the 2 point that you have. Which one is your initial, which one is your final? Identify it. That will definitely be your initial because time 400 seconds. So that is my initial. That is my final. Put in the value. Make sure the negative remain there. Don't do anything first to the negative. Okay? And then the concentration final that you have over here, 0.017 molar. Minus the concentration initial, 0.042 molar. The time final that I have is 800 seconds. Minus the time initial is only 400 seconds. Solve the mathematics, make sure the negative in front is still there. You will have negative 0.025 over 400 seconds. Okay? Press the calculator and you realize that the negative and negative will cancel out. So you will have a positive rate over here where 0.025 over 400 seconds will give rise to 6.25 times 10 to the power of negative 5. And what is the unit? Concentration is in molar, time is in second. So you will have ms negative 1. And that is the unit of this question, rate at 600 seconds. You have two rate over here, which is your average rate of reaction and your instantaneous rate of reaction. Make sure you can differentiate them. The calculation is actually very similar, only a bit of difference on how to draw the tangent. If it's an average, then you are drawing a tangent between a period of time. If it's an instantaneous, then you are drawing a tangent at that particular time. Okay? And that's it for this video. Thank you for watching. Don't forget to give me a like and subscribe to my channel for more videos. Thank you and have a good day.